Today, the global scientific community is once again focused on Harvard astrophysicist Professor Avi Loeb, following new updates about the mysterious interstellar object known as 3I Atlas. This object has sparked intense debate among astronomers, especially as new data continues to emerge. According to the latest findings, 3I Atlas is now recognized as the third confirmed interstellar body to pass through our solar system. It reached its perihelion, the closest point to the Sun, earlier this October. Some researchers now speculate that the unusual behavior of 3I Atlas may be evidence of artificial propulsion, possibly ion thrusters, directed jets, or even an advanced propulsion system beyond anything humanity has developed. This idea gained momentum when post-perihelion images revealed at least 7 clearly defined jets emerging from the object, pointing in multiple directions, including one aimed directly toward the Sun. As more images were captured, the scale became even more shocking. Some of the jets stretched millions of kilometers across space. The Sun-facing jets measured nearly 1 million kilometers, while the jets pointing away from the Sun extended nearly 3 million kilometers, far larger than anything ever observed from a natural comet. These findings left many scientists stunned. The jets from 3I Atlas are not optical illusions. They represent extremely high energy levels and material density that appear to defy known natural processes. According to plasma dynamics simulations, for a jet to resist solar wind pressure, which travels at nearly 400 kilometers per second, the material would need to be up to 1 million times denser than normal cometary matter. Such stability and strength would be almost impossible without artificial control or engineering. Even if the jets were caused by the sublimation of CO2 ice, the easiest material to vaporize, the surface area needed to generate this reaction would require an object at least 20 kilometers wide, far larger than anything the Hubble Space Telescope has recorded. This leads to another theory. 3I Atlas may have fragmented, and the breakup exposed a wider surface area capable of producing the massive violet-colored vapor jets now being observed. If this is true, the Sun's gravity may soon pull the fragments apart, revealing whether the object is simply a crumbling comet or something designed. Even more extraordinary, early calculations by Professor Avi Loeb estimate that the total mass of the emitted material could reach 5 billion tons. If this is natural, 3I Atlas may be one of the strangest objects ever discovered. But if it is artificial, it could be the first physical evidence of extraterrestrial engineering, a signal that intelligent life exists elsewhere in the universe. The latest analysis has only increased curiosity and concern. If 3I Atlas survives its solar pass and the jets accelerate to speeds far beyond 400 meters per second, reaching speeds comparable to human-built rocket or ion propulsion systems, the natural explanation becomes extremely unlikely. In that scenario, the energy output would match what we expect from deliberate propulsion, not random evaporative forces. Scientists agree that measuring the jet's velocity, mass, and chemical composition will reveal the truth, whether this object is a natural anomaly or a constructed mechanism. That answer may become clear before December 19th, when 3I Atlas reaches its closest approach to Earth. Professor Avi Loeb commented, "We have just 6 days before Christmas. Hopefully 3I Atlas doesn't deliver humanity a gift nobody asked for." Though said with humor, the remark carried a chilling undertone. So far, amateur astronomers monitoring the object reported that its core remains consistently bright and intact, showing no signs of major structural collapse. Whatever 3I Atlas, it appears to be holding together, moving with purpose, and still emitting energy. And that raises a final question. Is this a comet or a message? However, scientists are not dismissing the possibility that microscopic cracks or even engineered separation points may already exist, hidden beyond the resolution limits of current observation instruments. At the moment, ground-based telescopes are unable to directly study 3I Atlas because it remains too close to the Sun, sitting at a viewing angle of only about 30 degrees. Pointing sensitive equipment toward it risks severe damage or even total destruction from solar radiation. But that situation is changing. As 3I/ATLAS slowly moves away from the sun's glare, hundreds of observatories around the world stand ready, waiting for the first opportunity to capture high-resolution images in the coming days. The astronomical community is on edge, both anxious and excited, because even the slightest change in jet structure or velocity could completely reshape the narrative of this mysterious object. Is 3I/ATLAS simply an extreme but natural cometary event? Or could it be a technological probe, a message from a distant intelligence? According to Professor Loeb, the answer is close, closer than humanity has ever been, and it may change our understanding of the universe forever. As scientists continue monitoring its trajectory, the next few weeks are expected to be pivotal. If 3I/ATLAS has fragmented, powerful gravitational forces from the sun should gradually separate those pieces. Each fragment would follow a slightly different orbital path, eventually revealing whether this is a disintegrating comet or something engineered. A historical comparison already exists. In 1994, comet Shoemaker Levy 9 was torn apart by Jupiter's immense gravity, forming a glowing chain of fragments resembling a celestial string of pearls before crashing into the gas giant. So the question becomes, is 3I/ATLAS repeating a natural cosmic event? Or are we witnessing a controlled, deliberate process powered by unknown technology? Recent observations only deepen the mystery. The latest data indicates that 3I/ATLAS now possesses two massive tails, one trailing behind its motion and another extending in the opposite direction. Each tail stretches up to 3 million kilometers, far exceeding what standard comet models can explain. Something unusual is happening, and the world is watching. These latest findings have shocked astronomers, because in just a matter of weeks, 3I/ATLAS has generated structures on a scale normally seen over months, or even years. Back in August, the SPHERICS mission detected a diffuse gas cloud surrounding the object, measuring roughly 500,000 kilometers. But nothing at that time resembled the colossal gas streams now emerging from it. According to standard comet physics, forming a gas tail nearly 3 million kilometers long at a natural outflow speed of about 400 meters per second should require at least 3 months. Yet 3 months ago, no observatory, ground-based or orbital, recorded any activity remotely comparable to what is seen today. This implies one thing: the phenomenon did not develop gradually. It appeared suddenly, and that unexplained acceleration breaks nearly every known physical model of comet behavior, making the natural explanation increasingly difficult to defend. Dynamic modeling suggests that for a gas jet of this size to form in such a short time, the material would need to accelerate to over 1 kilometer per second, possibly even 2 kilometers per second. That level of ejection speed is far beyond what ice, dust, or vapor particles in a natural comet can endure without instant destruction. Even microscopic dust grains, normally among the fastest particles in comet plumes, cannot reach anywhere near these velocities. If the measurements hold, then 3I/ATLAS is not behaving like any known natural body. It may represent an entirely new category of astronomical object, one that blurs the boundary between natural formation and artificial design. The newest calculations have placed researchers in a difficult position. Either 3I/ATLAS is operating under a completely unknown physical mechanism, or it is not a natural object at all. No final answer exists yet, but one fact is undeniable. 3I/ATLAS has shattered the expectations of classical astronomy. As it moves farther from the sun and into a safer observational window, humanity may finally learn whether this is an extraordinarily rare natural anomaly or the first technological signal from an intelligent civilization. Recent trajectory updates show that 3I/ATLAS has adjusted its orbit slightly due to microgravity interactions, shifting by the equivalent of about 10 Earth diameters in just 1 month. This deviation is tiny compared to the Sun-Earth distance, but still significant enough to notice. At the moment, there is no indication that the object poses a threat to Earth, ruling out collision scenarios for the foreseeable future. However, some researchers are now exploring a more speculative possibility. that 3I/ATLAS could be a parent vessel releasing smaller components or probes in multiple directions, including potentially toward Earth. Although this theory remains unproven, the object's behavior has fueled intense debate. Adding to the mystery, astronomer Gennady Borisov, discoverer of the second confirmed interstellar object in 2019, identified a new object on November 2nd with an orbital inclination of 110 degrees, nearly perpendicular to 3A/ATLAS's path. This new body appears gravitationally bound to the Sun, and while it will never approach closer than roughly 510 million kilometers, the timing of its appearance, right as 3I/ATLAS reached perihelion, has raised eyebrows. Coincidence or coordinated timing? High-resolution images from the HiRISE system were expected to settle many of these questions, yet their release has been unexpectedly delayed due to a U.S. government shutdown. Although the data has already been captured, the team at the University of Arizona must wait for formal NASA clearance, a highly unusual delay for routine observational science. This bottleneck has triggered a new wave of speculation, not only about the nature of 3I/ATLAS, but about transparency. Many people are now asking the same question: why is information about 3I/ATLAS being withheld? Professor Avi Loeb has openly criticized the situation, arguing that bureaucracy is slowing down progress and that every delay is a lost scientific opportunity. He also called out conservative scientists who insist on forcing every unknown object into familiar categories, comparing them to outdated AI programs that simply repeat old assumptions without questioning them. Loeb noted that even if an object lacked a tail, showed no acceleration, and behaved unlike any comet ever recorded, some experts would still label it a dark comet, just as they did with Oumuamua. According to him, the problem is not the data, but the mindset. By trying to force 3I/ATLAS into an old framework, humanity may overlook something truly groundbreaking, something that could reshape our understanding of the universe and our place in it. Meanwhile, the latest observations, though captured only by amateur telescopes, show 3I/ATLAS maintaining a stable structure, traveling smoothly, and refusing to fragment despite its extreme outgassing. Many experts believe that if nothing unusual were happening, NASA would have already released the high-resolution images. Instead, the unexplained delay has intensified suspicion that something is being withheld. Loeb continues to stress that current data is not yet definitive, but the behavior of 3I/ATLAS is extremely difficult to explain using standard comet models. He expects that upcoming high-precision imagery and spectroscopic measurements later this year may finally reveal the object's true nature. He also clarified that the estimated 15 to 16% mass loss is only theoretical, based on classical conservation of momentum. If 3I/ATLAS is using technologies such as ion propulsion or engineered jet systems, then the exhaust velocity could be hundreds of times faster, meaning it would require far less material to achieve acceleration. As Loeb explains, the faster the exhaust, the less mass you need. If this is a technological propulsion system, then what we are seeing may only be a faint trace of an extremely efficient engine. This line of reasoning supports the bold hypothesis that 3I/ATLAS may not be a natural object, but a technological construct far beyond anything humanity has ever created or imagined. While the world waits for official data, NASA's silence has only deepened the mystery surrounding what may be the most unusual interstellar visitor ever recorded. In the days ahead, research teams will continue to track changes in the object's velocity and trajectory to determine whether it is accelerating or slowing down. For Loeb, this moment represents the true spirit of science: observing rather than assuming, questioning rather than dismissing. He argues that suppressing information or discouraging public curiosity is the opposite of how science should operate. Truth, he insists, should not be hidden out of fear. Loeb has also confirmed the first radio signal potentially associated with 3I/ATLAS, detected by the Mir-KAT array in South Africa. The signal contained two distinct hydroxyl absorption lines, a pattern often linked to water vapor or hydrogen-oxygen compounds. However, Loeb believes the signal was likely natural rather than artificial. The detection, known as the meerkat phenomenon, has sparked intense debate, with theories ranging from comet chemistry to extraterrestrial engineering. Still, Loeb cautions that current evidence is not enough to prove anything. Speculation is easy. Conclusions require data. Loeb emphasizes that the recent detection of CO2, carbon monoxide and water vapor by the James Webb Space Telescope on August 6th should not be mistaken as definitive proof of the object's nature. These molecules are common throughout the universe. If 3I/ATLAS is a natural object, he argues, these compounds may simply represent a temporary outer coating, dust, frozen gases, and debris accumulated during its long interstellar journey. As the object moves closer to the Sun, this surface layer could be evaporating, slowly exposing whatever lies beneath. But the alternative explanation is far more provocative. If 3I/ATLAS continues to maintain its structural integrity while emitting ultra-fast, multi-directional jets, it may point toward a form of artificial propulsion technology. Traditional comets only vent gases away from the Sun because sublimation is driven by heat. Yet 3I/ATLAS has produced jets that appear to be directed toward the Sun, a behavior never before observed in any known natural object. This anomaly is why the upcoming high-resolution images from the HiRISE telescope, as the object approaches Mars, are being considered a potential turning point. HiRISE's elevated viewing angle may allow astronomers to finally capture the true geometry and directionality of the jets, as well as measure their velocity, luminosity, and chemical signature. Loeb believes that within just a few weeks, once enough spectral data and detailed imaging are collected, the mystery of 3I/ATLAS may finally begin to unravel. Is it a dying comet, a fragmented relic from another star system, or a controlled, engineered construct traveling deliberately through space? For Loeb, this is what science is meant to be, not protecting old assumptions, but confronting the unknown. This is a moment to question what seems impossible, he says. In 5 to 10 days, we may finally learn whether 3I/ATLAS is breaking apart, or whether it is something else entirely. A luminous traveler drifting through the void, carrying the greatest question humanity has ever faced.